Before we do this next part, I want to just touch upon the three main operations in math. And we want to see how the new operation of squares and square roots fits into the math that we already know of: add, subtract, times, and divide. Because again, I mentioned before that the math behind squares and square roots is different than the math behind times and the math behind plus and minus. So our three main operations are add, subtract, times, and divide. Now we're looking at powers and roots. Okay, so whatever applies to squares, it also applies to cubes, power 4, etc. So how do they integrate with each other? Okay, so if we have pluses, add and subtract, and times and divide, the math is different, but we can do times and divide with add and subtract. We can essentially do algebra with these two. Okay, so these are compatible with each other, and I'll show you an example of what I'm talking about here. If I have 2 times x plus 5, okay, normally we would do brackets first and then multiplication, but because we cannot do this addition, because an x and a 5, they are not like terms, so we cannot combine them together. But we still want to do multiplication. So how do I apply multiplication when there's add and subtract? Okay, well, we know how to do this in that we can distribute this, and we end up with 2x plus 10. Okay, and we can check this. Does this actually work? Okay, we can actually try this with actual numbers. Let's say we have x is 3 plus 5. Okay, we know that 3 plus 5 is 8. 8 times 2 is 16. Do we get the same result when we distribute this? Okay, so we already know this is equal to 16 as a calculation, but with distribution, which again we don't need to do because we can actually add those two numbers together, we get 6 plus 10, and that equals 16. We know that's correct. Okay, so the math of add and subtract is compatible with times and divide. We can also say that since times and divide, or powers and roots, really are just an extension of times and divide, okay, powers are really repeated multiplication, just like times is repeated addition. These are in fact compatible with each other. An example of this would be if I had something like this: 2x all squared. Okay, if I'm going to square 2x, I'm going to get 2x times 2x. That gives me 4x squared. Okay, so I could just do it as multiplication, and then instead of using powers, the math of powers, I can use multiplication to verify that we can apply this power. And it's very similar to what we did here. We applied the multiplication across the addition. Here we can apply the power across times. So it works in a very similar way. Okay, another example would be a root. If I have the square root of 4x squared, okay, I have times in here. Okay, actually, maybe I'll do an example with divide. 4 divided by x squared. Okay, so I can apply the square root on the 4, and I can also apply the square root on the denominator. Just like I can apply the square across times, I can apply square root across the denominator, and I end up with 2 over x. I square root the 4, I square root the x squared, and that is perfectly okay. So this is fine. And we can see that this works with numbers. You know, I can have 2 times 3 squared, that's equal to 36, and that's the same as 2 squared times 3 squared. That's 4 times 9 equals 36, so that works. Okay, so that's perfectly okay to do that. We can check that with numbers. Same thing here. If I let the square root of 4 over 9, if I square root 4 over 9, I can do that on my calculator. I get 2/3. Okay, and that's the same as if I do square root 4 over square root 9. I can apply the square root across that denominator, and I get 2/3. Okay, so that works. So we have this compatibility of add, subtract with the next level repeated multiplication of times and divide. I have this compatibility with times with the next level, repeated multiplication or repeated division. And there's this compatibility here between those two. Where there's no compatibility, and this is the important part, between add and subtract and powers, there is no compatibility. We cannot do add and subtract with powers. That doesn't work. And I'll show you with numbers here. So if I have 2 plus 5 squared, the correct answer is 49. We cannot do this power across pluses. It's not compatible. Okay, I'm going to make this even darker because we want to make sure that we make no link between here. We cannot do add and subtract and powers at the same time. Okay, so if I tried to do 2 squared plus 5 squared, I'm going to end up with 4 plus 25. That's equal to 29. That's clearly wrong. Okay, this cannot be done because we know the correct answer is 49. So we cannot apply powers across plus and minus, the same as we cannot apply square root across plus and minus. 25 plus 144. Actually, I'm going to use a different one. I'm going to do 9 plus 16. That's going to be 25. The square root of 25 is equal to 5. However, if I square rooted those individually into square root 9, again, notice that there's a root, a power, and a plus. They don't mix. If I try to do powers, the roots across the plus, I end up with 3 plus 4 equals 7. Well, that's clearly wrong. Okay, so we cannot apply powers and roots across plus and minus. And there is no compatibility between powers and pluses. There is some compatibility between times with powers. There's some compatibility with plus, minus, and times. But there's no compatibility with powers and plus and minus.